Example 3 says, find the derivative using the chain rule. In this case, our inside function is not inside of a power rule in this case. Our inside function for p of x is located within the exponent of an e to a power. And our inside function of w of x is located inside a natural log. Let me show you how to go ahead and do these two. We start with p of x. The way to look at that is to think that this is similar to a y equals 8 times e to a power. And we know that the derivative of 8 times e to the power is just 8 times e to a power. So if I'm taking the derivative of p of x, I go 8 times e to my original power. My original power here is 12x squared. And then I have to multiply times the derivative of the inside function. Now, in this case, the derivative of the inside function is the derivative of 12x squared. Here, I've denoted the inside function just by the letter u, the placement of the letter u. So the derivative of the 12x squared is 24x to the first. Once again, that's a single term, so I am going to clean the derivative up algebraically. If you take 8 times 24x, you're going to get 192x. So take the 8 times the 24x. I put that all in front. And then e to the 12x squared. So there's the derivative in its most compact form. Let's take a look at w of x. We have natural log of a polynomial. So you should think natural log of u, where our inside function u is 6x to the third plus 2x. Now I know that the derivative is going to be of natural log is going to be 1 over u. So as I take the derivative of w with respect to x, I write 1 over the inside function, 1 over 6x to the third plus 2x. Then I multiply times the derivative of the inside function. The derivative of the inside function is 18x squared plus 2. If you want to make that into a single fraction, then you can simply multiply the numerators together. There's an implied 1 in the denominator. So multiply the 1 times 18x squared plus 2. You get 18x squared plus 2. And the denominator would be 6x to the third plus 2x. And that's as simple as it can get, as simple as we can write the derivative. Notice that the derivative here of natural log of a function is essentially the derivative of the function in the numerator and the actual function in the denominator. So if I have natural log of a function or of an expression, then the derivative is a fraction where the expression goes in the denominator and the derivative of that expression is in the numerator. Moving to example 4, we can see that our functions don't always have to have an inside function, which is a polynomial. In the previous few examples, namely in example 3, our inside function was a polynomial. The you-do problems, our inside function was a polynomial. And in example 2, the inside function was a polynomial. Obviously, our inside functions don't have to be polynomials. For instance, here, r of x equals natural log of 5 times e to the x plus 9. Our inside function is 5 e to the x plus 9, which is an exponential function. H of x is equal to 7x squared plus cosine x, all raised to the 7th power. Our inside function is a sum of a polynomial piece and a trig piece. So let's find the derivative of these using the chain rule. We begin with r of x. When you see r of x, you should see a function which is natural log of something. Let's call it natural log of u, where u is the inside function. We know how to take a derivative of natural log. If you remember from the last example we did, we could write it as a single fraction right now. But what I'm going to do is I'm going to write it in the long form first. So if I take a derivative of natural log, I take 1 over the actual inside piece, the 1 over u, where my u now is 5 e to the x plus 9. And then I have to multiply times the derivative of the inside function. Now, in this case, since our inside function is 5 e to the x plus 9, the derivative of that is 5e to the x plus 0. Derivative of e to the x is e to the x. Derivative of a constant 9 is 0. And if you wanted to rewrite that, you could rewrite that as a single fraction, 5e to the x divided by 5e to the x plus 9. Just as a note, don't try to cancel out this 5e to the x on top and bottom. This plus 9 does not allow us to do that. So I cannot cancel out an e to the x on top and on bottom because I have multiple terms on the bottom. You can only cancel out when we have things multiplied, but when we have things added, it's not going to work out. So don't cancel out that e to the x. Let's take a look at h of x. You should think of this as a y equals an expression which is like a u to the 7th power. So if you're taking a derivative, you should take 7 times that expression to the 6th power. That expression is 7x squared plus cosine of x. And then you should multiply times the derivative of the inside function. Now, the inside function is 7x squared plus cosine. Derivative of 7x squared is 14x. The derivative of cosine is minus sine. And that would be your final answer. Now, some people will distribute this 7. The 7 you can't distribute into the 7x squared plus cosine x part because that part's being raised to a 6th power. But if you want, you could multiply the 7 times the derivative of the inside function. So I'll go ahead and do that just so you've seen it once, so you know how to rewrite this in numerous ways. H prime of x would be equal to, I'm going to take the derivative of the inside function and put it up front. So 7 times 14x is 98x minus 7 times sine of x. And then that is all multiplied times 7x squared plus cosine of x to the 6th power. So if you want to clean it up, you can clean it up like that. These are both the same expressions, just one has fewer components. So now that you've seen that, I would like you to try to do the following two problems. Find the derivative utilizing the chain rule of f of x and g of x. You can see f of x and g of x here on the slide.